So I'm really excited about what you're about to do here, because this is where you really start to go from, just learning about this stuff to implementing what the pros do.
Yeah, and it's funny. This used to be a mandatory thing if you wanted it to work. And for a long time, a lot of Android developers were not doing this, and it's one of the differences why iOS initially was so smooth, and Android was so jerky for long lists of data, is because they weren't implementing this pattern. So again, this is going to follow the same order that we did for the custom adapter, except we're going to write a custom adapter the way that, again, the pros would write a custom adapter, and the people that are taking this course should write a custom adapter. See, I was like, oh, do it? I don't have it yet. You can slowly see me realizing that. I got so excited. Back up. Beep, beep, well, normally I would just start writing that code and let the errors just sit there, but that's not appropriate. You should deal with the things that you've built in the right order.
Yeah, single focus when coding.
Yeah, it can be really easy to get lost if you try to open too many threads at the same time.
Yeah. Too many brain threads.
Too many brain threads. So here we have our place again. We're also going to be dealing with this M pop-up string that previously in the other one we weren't really addressing what that's for.
It was just hanging out.
Yeah, and that's going to be cool. This one's really all about efficiency of memory and reuse and recycling. It's very green cast that we're doing right now.
And when would you say in kind of Android, the Android community of developers, that it became common to do this? Like they actually started picking up on, okay, this is something that's important to make possible.
I don't know. I think that really good Java developers knew this pattern already. I think that initially the people who were probably first excited about Android knew a little bit of Java, and so there was just a lot of stuff done without it. But a pro in Java would have implemented this right away. It's just that in the very beginning, there wasn't a lot of resources for people to kind of share some of these professional tricks with each other. And so this holder pattern was just not as well known.
So would you say this is one way for an Android developer to distinguish themselves to other developers as like, oh yeah, I know how to deal with this. I know it's important to deal with this. Yeah.
And also it's a matter of just pride. I mean, I don't know about you, but when I was first using a touch device phone, I would just sit there and scroll the thing back and forth and just admire how smooth it was.
Right.
And so, the more that you can empower yourself to write something that is, I don't want to say breathtaking, but I mean, is magical in that way. I mean, the more that you get joy out of using your own application.
Yeah, it just feels good to use it.
Yeah.
You want to put it in other people's hands.
Right, and they want to keep it. And then you have to grab your phone from them because they won't give you your phone back.
That's the experience you want as a developer, when you can't get your phone back from your friends because they're too busy just playing with your app.
Yeah, check this out. Yeah, that's really cool. Can I have it back now? I need my phone.
So far, same stuff.
Same stuff. I'm not sure if I used I used the generator before, but again, the constructor is just saving references to what we're going to pass in, the row, a context, and the data itself that we're going to, blend together. Again, I'm just taking that get item and get view, going to bring those in. So I have the right method signature. In this case, it was not in the right place. I like to put my constructors at the top. That's good practice. And again, we're going to remove that return statement and replace it with the holder pattern.
So that's what it's called.
It's called the holder pattern.
Just before we get into it, any kind of overview as to why it's called holder?
It's called holder because you're literally making a placeholder for what you want to recycle. So by using that object is kind of an intermediary, you actually have an ability to, when something is done that was just inflated for the purpose of laying stuff out, you can just kind of switch the references rather than having to try to find it. And that's one of the reasons why this is called convert view, is that literally is the view that gets passed in that could be converted to be reused. So here you have private static class. I'm probably hesitating on exactly what to name it. So you can tell I hesitated because of that extra space. I got nervous there. Like, well, what should I name this?
One too many white space.
Well, I got weird because it was placeholder, and that's weird because it is kind of a placeholder. And then I was like, was that clever or is that misleading?
Why didn't you call it recycle bin?
Because that reminds me of Windows and what you throw away, and that's not what we're doing here.
Okay, got it. Yeah, this is not Windows 8 mobile.
No. This is not. This is Android.
This is Android.
This is an international operating system. So here we have just the image view and 2 text views. So what you want to do is just figure out all the different things you actually have to change. What is going to be reused? So here, again, we're just very simple. I want to save a reference to 2 text views and an image view. Import those guys real quick. All right. So normally, again, for this, I still wanted it to be simple, so that's why I renamed it row again, but probably would have just called it convert view after doing this a bunch of times.
Mm-hmm. You mean on line 36, you took convert view and just renamed it?
Yeah. Well, because it makes sense for the first time that you're seeing this change, right?
Right.
So again, the first time your app starts up, there are no rows at all. So you do have to allocate them initially. So if basically we get this convert view, right, like this thing that comes in and there isn't anything, we got to create a row to begin with, right? So if you can only see 10 items on the screen, and you have to at least allocate 10 items at some point, and that's what this part of the code is doing. And even though it looks like it's just 2 lines of code, actually that process of inflating the view is relative to a computer actually a pretty expensive and long process.
Because it's got a lot of data and a lot of rows to set up. And
actually, I'm not sure about this, but I believe actually most of it is because that XML might be at this point actually on disk, so it actually has to read it in.
Oh, okay.
I'm not sure about that. It might be that it's just doing the parsing of the XML, but I'd have to look at it.
But it's both processor and time expensive?
Yeah. Well, time expensive because it's processor intensive. Because you have to actually take all that XML, read it in, allocate every object for what it represents, et cetera, et cetera.
And how do we know? Do we know how many it will auto-inflate this first time through? Do we know what it keeps, 10 or 12 or
we don't want
5?
to. We don't want to.
Okay.
Our responsibility at this point is to respond to a call for getting a view. So if it's asking it for it 30 times or once, like we don't want to be concerned with that until that becomes a bottleneck. So here you can actually see like we're actually creating a new one of those placeholder classes.
On line 46.
Mm-hmm. Now, this is the pattern that I'm used to, but you can technically do this another way because it's a static class. Again, this is the way that it's clear. It's the most clear to kind of see. But we're doing the same thing we were before, only rather than setting the row itself to a reference, or these references as being what's going to change, we're actually saving the reference inside that holder object. So again, we're getting the text view and the zip code and the image view. And now this holder is all those different variables are just pointing to those pieces on the row that we've inflated. And here's the magical line right here. Set tag. That particular method call is amazing. You can just use it to store any little reference you need. In fact, we use it twice here, just to show you like how flexible it is.
And is there anything under the hood that's going on that we should be aware of, or is it just magic?
Well, the magic part is probably the fact that getView is passing us in the convert view. But no, it's set tag is literally it's literally a field that is of object type, so it can point to anything. So whatever you give it, it'll point to.
Got it. Very generic.
Mm-hmm. See right there. See that get tag returns an object.
Mm-hmm.
So you just have to typecast it when it comes out. But look at that. See all this code from 43 to 52?
Mm-hmm.
That's only the first time it runs.
Right.
Otherwise, we're running just line 55. That's a much quicker operation than all that other stuff up there. So you can kind of see how much faster it is already.
That's really cool.
And from here, we're basically doing the same thing that we would if we didn't have the holder pattern. We're just taking the data and, getting a place object out of it. And I could just read off what I'm doing here, although I'm more concerned with the fact that I was so low on the screen. And then we're setting the view to reflect the data we need to display. So notice that we're not using the references from a find view by ID directly. Here, we're actually saying we've already gotten those references at some point, either by doing it the first time or by getting the tag that points to that particular holder. And now we're just setting the text on those pointers, basically.
Right. I'm still concerned with how sparse our placeholder class is.
Well, that's the point, right? Like, if that class had a lot of overhead, we would have to deal with it. But here,
sure.
I mean, those literally, because there are just variables, they're so small. They're just pointing, right?
Mm-hmm.
I mean, I forget in Java what it is. I think it's for a 16-bit. Like, that's just a memory address.
Right.
The holder pattern definitely, like, I've gotten more of appreciation for it. The more that I have done, like, gone back and done more low-level programming with pointers, because then you get to see actually how beautiful this is. It's really leveraging the fact that Java object reference variables are just references, and that it's really the allocation and processing information that's really expensive. And
other than this pro smooth scrolling list view, where else might holder pattern be applied?
That's a good question. I would say anything where you need to have kind of a moving window, or you want to recycle objects.
Mm-hmm.
It could be, I mean, I could definitely see if you're processing a large amount of data, it'd be useful, especially if you can't necessarily process all the data at once. You can make a rolling window to reuse. For me, I was introduced to what this concept was and then never really understood the application of it until I had to deal with views.
Got it.
Yeah, so there we are. It's just kind of the same thing. You notice this time around that 63, I was much smarter about, like, I don't want to go through that debugging. Yeah. So now we're going to go ahead and plug that stuff in. But, this idea of, like, recycling the view, that concept, I think, is really important as much as possible. And we're going to see it, the same concept of, like, reuse, recycle again. There's another thing that the holder pattern also prevents us from doing, which is if we had a list view of, like, 1,000 objects, like, you really don't want to allocate 1,000 view rows. So it's not just about the speed and fluidity. It's also about the size of what you're doing.
Yeah, that's one of the things that I noticed studying both how people develop for the web and people develop for mobile, and really thinking about mobile as, appreciating that you want to be considerate about resources and how much you're going to take up.
Even though they're supercomputers, they're still low resource environments.
Right. And even if they become faster and bigger, which they will, but as they do, you still have this real desire to manage your resources well. And that is what I think shows your professionality as a mobile developer.
Yeah. On top of that, it also helps you write stuff you're proud of and go home on time. Because if you're copying and pasting and having to change around a lot of code, instead of writing like, oh, I've written this twice, I can make this its own method. Then you're writing a lot of extra code you don't need to. And if you can kind of get comfortable with, you know what, I'm just going to do this once and then I'm going to reuse it as much as possible, you literally just have less code to go through. So again, we're checking for null, even though we know it won't be. Setting the adapter. It looks the exact same from this particular standpoint on the activity level. Oh, and here's my favorite part again. I love this every time. I kind of wish we could just like slow motion this. Except look at this. I'm like, oh shoot, didn't do the new on the first time. And then there it is.
It's like so fast the IDE takes a while to catch up.
Yeah,
it's like what are you doing? I can't handle all that at once.
Like, oh crap! Did you use? What do you? Okay. Everything's cool.
Got it.
Everything's cool. Except
for I call it position.
I started calling it position. Yep. We're still going to do the name of place just so we can show the functionality of it clicking.
I wonder if we could like submit a code smell to the Android OS guys and just be like, hey, all right, position.
You should make it consistent. You know what would happen, actually? They'd probably give you a reason about why they did that.
They probably have a very, very complex and detailed reason.
And it's probably that like they were lazy. No, I'm kidding. I'm sure there's actually a good reason underneath the hood. I don't know what that code looks like directly. And there we go. And you see, it's hard to tell. I think I mentioned this earlier. It's hard to tell how much smoother it is because literally Genymotion is turning my laptop into a phone. Right. But on any device, I mean, you can feel the fluidity on how smooth it is.
And if they wanted to at home, they could just double, triple, quadruple the data set.
Mm-hmm. Or actually, where you'll probably see it even worse is if they add a lot of view elements to it, a lot of image views, things that would make that first part of the if statement get longer in code. Yeah. And so now here, this is great. Now we're going to do the exact same trick of using the get and set tag, but we're going to use it to recycle a listener.
Okay, so this is a whole nother concept going on here.
Yeah, this is a whole nother concept under the same category. So I'm going to make a listener, or a listener. Listener. And we're going to see that beautiful just, pop it all out. So this on-click method, if we wanted to make it so that when you touch on every picture, it does something different than selecting the row, we would have to create one. If we were to do it the normal get view way, we'd create one for each time we allocate a row. Or if we did it the old way, we would allocate it for every time we see a new row, every time the view is received. But instead, because if you click on that, the only thing that really changes is what thing you're clicking on. The functionality of I'm listening for someone to touch this image view is still the same, right? Mm-hmm. So we're going to go one level deeper, and we're actually going to take the image view and set that listener on it. So, right, it's just reusing the same listener. And now we have this problem of like, well, how do I tell which one to use? Normally in that on-click method down there, because of the fact that it's a new view on-click listener, we can't just ask for the position. It doesn't have any concept of that. But we can take position as a integer or as an int, save it as an integer, which is an object, and again, set tag can just save any object. So now we're just saving the position so that when this comes in, that view, which we know what it's listening for, we can just pull it right out so we can tell where it came from.
I love it. Recycling not only the data or the in the memory, but the functionality as well.
Mm-hmm. Yeah, there's only one new keyword there. So we're actually saving memory and saving functionality. And also it's much clearer to read. The readability is much better because you can look at this pop-up listener and know, oh, they're all doing the same thing. Mm-hmm. But you could save anything. In fact, one thing that you could do If you want to do something really complex, you could create another class and save like position and, time that the person clicked on it and whatever other data you wanted, and do this exact same thing and pass that object around so that you could, get some other, I don't want to say get context because that's actually an Android method call, but get some context about what was happening.
M pop-up that you mentioned earlier.
Yeah, so that's
putting
just
it in there.
It's just another string that was different than the name that I just put in there. And here we are just creating, a pop-up toast that'll show when we touch the image.
Give ourselves a little feedback.
Yeah, let you know it worked. Clear that up. Kind of get the subliminal Delta program brand right there. There we go.
There we go.
So click, click, click. Still liquid smooth. You can see Bike Shop and Camera Fix down there. And there we go.
Excellent.
All with the same listener.
And now they can go discover all the little secret messages.
Yeah, I love that place too. You got space?
It's awesome.
Yeah, but you can use this for anything. You can use it for switches. You can use it for multiple buttons on your item. Just as long as you follow some good design principles and don't make it so that it's, your thumb is too big to actually discern where the content is.
Or everything gets hit.